HVAC, again, on the electricity theme, ECM motors is something that we should all be asking for in any of these products, whether it be a forced air gas furnace, an oil furnace, an air handler, an HRV. All of these products now, if it's an air-moving device, you can get it with an ECM motor. And an ECM motor is an electrically commutated motor. And that's just a mouthful to say it's controlled by a computer. Normal ones are a permanently split capacitor, and they use an awful lot of electricity. If we go, and this is in US dollars, so just bear that in mind, but it shows a great comparison. The savings on an ECM motor compared to the same equivalent permanently split capacitor motor over a 10-year period is almost $2,500. That's in a furnace. Your consumption in kilowatts is a difference of almost 3,000 kilowatts used for that same type of appliance. The other benefit to an electrically commutated motor is that it gives you a ramped up airflow. So if you are putting a forced air system in your house of any kind, you've got a nice even heat. You'd be hard pressed to actually tell that the unit's on when something with an ECM motor is running. It's quiet, gives you an even heat. It will ramp up to overcome resistance. So if somebody hasn't quite ducted something right, it will ramp up to provide the extra oomph to get the air to where it needs to go. They are more money, probably on a retail level of about $800 to $1,000 more for a furnace with an ECM motor as opposed to one with a PCS motor. But as you can see over the life cycle of it, you're going to recoup that money in about 5 years.
Now, is this just for forced air furnaces or for boilers?
Well, if you have a boiler and you're going to move air at some time with it, like an air handler, that's what
HRVs.
The HRVs are available with
Vanny
Vanny, Venmar, Life Breath. They all have them available. Yeah. Well worth the money investment, because you can see, again, if we're talking payback, again, US dollars, so maybe in year 4 in Canada here, we might pay that for that.
So there are ones with the ECM motors and ones without it?
That's right. That's right. And normally when you go up in a higher efficiency, and solely speaking furnace, if you move into the higher efficiency products, you're going to get an ECM motor with that, because you just can't get those efficiencies that much higher unless you move into things like that. So that speaks to the production side of the HVAC. And just quickly, the delivery system. Like I said, if we have a ductwork system that's not piped right, we're going to use more electricity, more power in that motor to get that air that we want where we want to go. Same thing for piping for an in-floor system. It's got to be done right. And the way we use that. If we zone our rooms, if we only heat where we're living and keep the other rest of the rooms at a lower temperature, we're not going to use that much fuel, we're not going to use that much electricity to move that heat around the home. So, to sum up, if you're looking at the energy efficiency of a home, number one is your site, and we spoke about that earlier, about orienting it, overhangs, making sure our exposure's protected. Our structure, from our air tightness in particular and how we build, is very important. Our envelope, sealing it up, like I say, you can't use enough acoustic seal and tuck tape. It's cheap and it works. Our mechanical systems, this is the one point that's going to use energy year after year after year after year. Make sure you're looking for the most efficient product out there. And our electrical use and how we're wiring with that in mind. So if anybody's got any questions before I turn the floor over. Sorry, go ahead.
The bridging you refer to with the 2x4 and 2x6 lumber, you put a panel over it. Is it fair to say that the bridging is still there, but it's just reduced?
It's reduced. What we're doing is we're putting our value on the outside of that, so we're taking that 2x6 from 6.8, adding another 5 to it, essentially, if we're using 1 inch of foam. But we're stopping, if you can imagine a steel stud now, how bad the thermal bridging would be with that. It's the same idea with wood, but not to the same extent.
I was considering building up in my place, and I basically paid 2 designers who knew nothing about all these things you're talking about. So who do you go to? Is it like, how many people are knowledgeable? Do you come up with the designs for how to install these efficiencies? Or
That's a tough question, because normally you go to an architect, and you would have an architect design your home. Now, in the past, we've all gone to architects that have said, yeah, we can put big palladium windows here, we'll do your kitchen like that, make it a nice open concept, the neighbors will love it, and you'll sell it for lots of money down the road. It's tough to find somebody who's going to look at all this. And I would say an energy evaluator, somebody who is has some accreditations in the Energy Star field, because they're going to look for things like that. More so in the LEED, because it's that much more in depth again. It's nothing to have somebody review an architect's plans and make suggestions on your behalf to then take back to the architect and put into your design. But there are architects out there that do it and are very good at it. But I will say we do about 1,000 HVAC designs a year through our department, and just simply from seeing those plans, I've seen 2 homes in the last 5 years that have actually taken into consideration summer sun angles. So they're there, but they're few and far between.
I think there is a list of involved architects that switches, some list of folks in the Kingston area that work very closely with home builders to make sure that the architectural and building and the sort of built together.
And that would extend even to landscaping. Barty was here the other night speaking as well, so
Yeah.
having that contact list, and obviously through Switch, you're going to find people that can provide that for you. Anybody else? Thank you very much.
My apologies for forgetting about you. Very important part here.
I'm easily forgetting.
So you can see that, like a bottom-up, like what Jeremy is really talking about, is a bottom-up approach to whatever you're going to do, to make sure that you optimize everything as a whole. And tonight we're talking about electrical power, so you can use less or you can use more, right? And so this picture here, allows you to think about all those things that you might do to minimize your electrical power before you actually do something. So.